Welcome, everybody. Thank you so much for coming, spending your Wednesday afternoon with me. My name's Paul Yuknewicz. I'm one of the heads of product in Azure. My team works on serverless and PaaS and functions, but we also kind of contribute to other things like app service and container apps and security. This is a talk that's in just kind of a subject matter that's really close to me. Hopefully close to you too. You know, how to get really pragmatic and how to secure our cloud applications. I'll be honest, over the last year, we've really been humbled by the level of, security exploits and vulnerabilities that have been tried on us at Microsoft. I spent the better part of this year, especially this summer, doing absolutely nothing but improving our security in the platform and also working with all of our internal services, whether it's like Office 365 or our health platform, just helping all of our own cloud services kind of apply security best practices, and we learned a lot as we went. So what I'm hoping to do is have a little bit of fun and also share some of the hard lessons learned that we had securing, and hopefully together we can all get in front of these bad guys who are trying to make our lives not so good. So that's what we'll do today. So what I want to do, I want to talk about just a few of the attack examples that for me are top of mind. If I miss any, I'd love to hear from you all too. And we're going to go from very basic prevention all the way to pretty sophisticated prevention. We're going to talk a lot about going passwordless and using identity. I think that's one of the absolute things I hope everybody can take away today. Also from the networking side, network security is absolutely paramount. And we're going to talk about how to do network isolation and setting up network perimeters and how to really think about that and how to actually do it in Azure. Hopefully I have time to show you some tips and tricks. I can show you some tools. I can show you how to debug and diagnose some of this stuff as we go through. So hopefully you get a bit of conceptual, a lot of hands-on. I am providing you with all the code, including the infrastructure as code, like the actual bicep code, so you can apply these policies and these templates for your apps right away, and you can kind of try it out. You can actually take one of these templates and deploy it in under 2 minutes in your own Azure subscription and see what's going on. So hopefully that sounds good. Okay, that's the plan for today. See if the clicker works. Did I turn it off? There we go. All right, let's talk about the Midnight Blizzard attack. If you're interested or you want to Google for it, we, with our MSRC team, we've published guidance on what happened with Midnight Blizzard. We've published follow-on guidance on how you can prevent that. And I think it's really good guidance. And what I hope to do is go like a click further, saying like, here's actually how you take an Azure service and you do some of these MSRC practices. So Midnight Blizzard, so state actors and hackers basically leveraged a multi-phased attack and a coordinated attack. First starting with our legacy servers, like our legacy dev and test servers. You can kind of think of those servers that we have that maybe haven't been patched in a while. We do, at Microsoft, I think we're pretty good about OS patching. But there's the next level of things that maybe we hadn't thought about, which is we started with secure posture, from maybe 5 years ago. And so we would set up service principals in the Active Directory, now called Entra. And we had these service principals that effectively had full God mode access to other things on the network. And so these servers, even though they weren't as important to us, they were dev test in nature, they had these legacy credentials assigned to them. And those credentials now had keys to the kingdom to get in. So I think there's we'll talk about kind of the lessons learned and what happened, but kind of keep that in mind as as things age, they start to create more and more vulnerability. And the absolute key, in my opinion, is to have a strong DevOps process and a strong auditing process to really find and mitigate this. It's kind of like changing a whole bunch of locks. Okay, so once there were these dev test services that were findable, now there are some service principals, and then a combination of that and just using public information on the internet Little hints about, well, who are the usernames? What are the email addresses? What are the Azure accounts? What are some of the server names, right? People can watch demos and see the server names. Well, those come up, or people blog about it. So there's all this public information that was out there and for sale on the black market, effectively. And with that information plus a few of the keys, that allowed the first breach, which is the attackers are on our network and on our servers, the ones that we thought were less interesting. But what got really scary is they had some of these service principles that we had basically forgotten about how powerful they are, and they could get in. Then the next thing that happened, using some of this information, like let's say Paul Yuck at Microsoft.com. So they've got my address, and then they could start a technique called password spraying. I don't know if you're familiar with that, but it's kind of like hammer attacking, someone just guessing passwords using a bot that can rotate through guesses. And usually what happens, if you attack a modern thing over and over with the same password, it shuts you down, it slows you down for an hour, a day, like you can't just keep doing it. But these password spray attacks are very sophisticated. They keep coming from different addresses. They use VPNs, they use coffee shops, they use all these like really diverse networks and identities to come from. So it didn't look like a single attacker trying to hammer a password. It just looked like a bunch of anonymous things that, oh, like the password didn't work this one time. Okay, no big deal. But every time the collective was getting smarter and smarter and eliminating things from the list. And eventually, you're able to do some smart guessing and hoping and get through with passwords. So we got old service principles. We've got passwords that people were able to guess or hammer attack through password spraying. And then there's another flavor, which is there's a number of these OAuth apps. So the third kind of breach was OAuth apps. And remember, OAuth apps, when you join an app to Entra or to the directory, in the original days, they would all also have a service principal. A service principal is just another flavor of a secret that you have on your local disk, right? So it's like having a certificate. It's like having a password. So these OAuth apps get these identities with a password on local disk, and they happen to be admins, which allowed the last terrible level of attack, which allowed these attackers to basically own servers that we actually cared about. So they were able to hop from these dev test things that we weren't thinking about to the networks that had the important prod things, use these OAuth apps that basically had admin, and off they went. And even once, it was kind of like, I don't know, Settlers of Catan or something. So they attack one settlement, and then they get some passwords and some emails and some more information, customer support information, and they go to the next one and attack the next one. So this was an awful attack. We unfortunately learned a lot the hard way, but we're going to come back stronger. I'm going to teach you how to deal with this kind of stuff. All right, so basic strategies, number one. I'm going to be a little cheeky. Hopefully you're okay with that, with some of these memes. So most important thing, I know it's obvious, but using modern patch servers with modern DevOps practices, with modern vetted secure supply chains, libraries, registries, absolutely critical. If you think about some versions of Windows Server, don't even have the modern OAuth standards or the modern identity standards because it wasn't invented yet, right? So you want to be on the latest version of an OS, the latest version of a framework, the latest version of your dependencies. You want to know where your dependencies come from. It's really just making sure the infrastructure you have is modern and patched. Another lesson that we learn is, only install exactly what you need. Narrow that surface area, because every one of those pieces of software, servers or daemons on the machine, are attack vectors that can be owned and used against you to attack you. So it's kind of like limiting the number of roles and services that you install, limiting the number of ports, just really locking it down. That stuff matters a lot. And I think you can learn from the last case study, it's really important to separate the concerns of your servers. So lower risk things like dev test, those are great to have. They should be a little bit more permissive, but absolutely keep those separate and never mix them with your prod resources. Keep them absolutely separate. Separate identities, separate networks. Physical separation, if you need that. You just don't want any buddy to be able, hop from something less privileged to something more privileged. All right, enough of that. So going on, we're going to move from ultra basics, kind of obvious stuff, to hopefully things that you haven't heard. Okay, so let's talk about going passwordless. I think if you think of the root cause with what I talked about with Midnight Blizzard, it was 2 or 3 forms of passwords. Passwords are kind of nasty because they stay around. They're machine readable, they're human readable, they're copy and pastable, right? So anyone gets that password, it's as good as a way in. It's kind of like having the key, that you give to a ex-girlfriend, boyfriend, partner, like that key is good, like forever. You're just giving it away. So we want to go passwordless. The number one thing I would try to do is to go managed identity with all your services. That will cover your service identities. Also, there's a whole new way to do things. So there's pass keys, which are like virtual keys that are on your device that rotate. There's also these things like a FIDO key or a UB key. I brought mine with me just as a prop. They're as good as one-factor of authentication. So instead of needing one password, you can use one of these. And then you can have other things like it has to be on a trusted device. You have phone auth. So you have a phone auth and one of these. There's a number of things you can pair together, and it becomes really hard because someone would have to, ambush me, get me to unlock this, and the code into this. And it reduces the easy stuff. And I think a lot of these attackers are going after the easy stuff. Not only do you want to not use passwords, but the next step is turn off the ability to even use passwords. So if you see us talk about local auth is talking about we locally allow you to authenticate with passwords. You want to turn off local auth as soon as you can. And I know it's a journey to get your users, your customers, your partners, your machines off of passwords. It's a journey. Believe me, I know. But when you do, as soon as you can, and you feel like you can do it, turn off that password capability. And then there's no way, because you're kind of only as secure as your least secure way in. So if you allow passwords and a more secure managed identity, well, anyone who still has that password or any password you've forgotten about that's lingering around, that can still be the thing that is used to own you. In our case, that's absolutely what owned us, right? It's these service principals and these OAuth apps that we forgot about, that we weren't inventorying, that we weren't expiring. Those are the ones that got us. Use multi-factor auth too. Absolutely critical. I think we know this, but these are just kind of good hygiene reminders. Never accepting unrecognized requests. So even like these things, the phone auth, a new favorite thing is they'll start hammering me and I'm like, what the heck? Why is someone asking me to sign into Microsoft? No, right? So any one of those, I wouldn't, if you don't know exactly what it is, just say no, because they actually could literally be threats. And a number of our employees were attacked exactly that way and still are attacked that way. All right, the last thing, if you absolutely must use a password or a token or a secret, we have a technology called Key Vault, also an open source. There's things like Vault. Just please use one of those and try to use it sparingly. But I understand, there's a number of legacy services, there's third-party services that there's no other way in. You have to use this sort of password. Then you can use the Key Vault. And we have guidance online published about how you can set up Key Vault to do an auto rotation and kind of an auto expiration so that at least even after a while, you're required to re-authenticate the Key Vault key. All right, next, access control. So once you have an identity, and that identity isn't based on passwords, the most important thing is setting access control. This is another one we learned the super hard way. I think the easy and the default thing to do was to make things admin, right? It's hey, I got to get this thing working, set it as admin. We'll lock it down later. That's what kind of gets you. So, we talk about a principle of start with least privilege. I highly recommend that if you can. We're getting a lot better at Microsoft saying, hey, for these common scenarios, here's the least privilege you need to grant. And those RBAC grants will also save you because then you can make sure, hey, this one service is only allowed to do what it's intended to do, and it can never be an attack vector for an elevation of privilege. And I think I've said it like 100,000 times. Beware of service principals. Use them very sparingly. Look for approaches with managed identities instead of service principals. And more and more, the more I've worked on it with my platform team, we've been enabling managed identity absolutely everywhere. So if you can find one for me, a thing that doesn't use managed identity, please tell me, because we've been trying to turn that over to managed identity everywhere. And I feel pretty good about it. Okay. Last thing, let's talk about network isolation. I'm going to do a deep dive on this later because I feel like I have to because it was hard for me to learn. Maybe you'll get something from it. But this is about fencing your networks. By fencing your networks, you're automatically giving physical, or at least network software level separation of assets, right? So we want to keep protected assets on their own networks. You want to have only one pinhole through that firewall from untrusted networks into the trusted network, and it's going to give you a lot more depth of defense. So what I literally mean, so we have this concept of VNet. Folks familiar with VNets? Or VPCs, if you come from AWS world. So yeah, VNet is kind of like your private network, your private subnet, your private network. It's your secure thing, and we have at home, we probably have routers, right? You have the outside kind of dirty internet with all the threats, and inside our network, it's one step safer. Then you can imagine if you have a server on your network, you want that on its own network too. It's like all these things that have the data and have the resources that you want to protect, you put them on separate networks. And in the limit, what we actually recommend, and what we actually do inside of Microsoft is every single dependency, we've gotten into the practice of putting it on another network. And so the VNet is kind of this trusted array of networks you can use, but even within that VNet, you can partition into different subnets, and there's only one way in and only one way out. It's kind of like a NAT, right? Only one way in, one way out. And at that one way in and one way out, we can use auth, we can use allowless, we can absolutely lock down the network to trusted traffic. And we kind of think about now, like all traffic is untrusted by default until we trust it. And that's been a flip in mindset for us, but it's really helping us. So far, so good, kind of making sense. I'm going to show you now. All right, so one thing, this might be a good one to get a picture of. I'll send it to you afterwards. This aka.ms/functions-secures-samples. Everything I'm showing you here, everything that my team's worked on for the last year is secure by design. And we have from like easy to hard examples of how to secure things. You can play with them now, you can play with them when you go home. All right, so what I'm about to show you in the sample is based on a few concepts that I want to tell you, and then we're going to look at them again and kind of reinforce them in code. So the first, most important thing of this whole hour, forget everything else, managed identity. So managed identity is, it's kind of like there's an identity, and I think we've known about identities for a long time. Like we all have an identity at our work. Like for me, it's Paul Yuck at Microsoft.com. We have identities at home, Paul Yuki at Hotmail kind of a thing. I'm dating myself with Hotmail, sorry. We have these identities, but now we want that identity to be like very virtual and to be backed by keys that rotate, preferably with no password at all. And that identity and that set of credentials are things that we can expire very easily and not have to worry about. So a managed identity lets you do what a password can do and a whole lot more, because you can decide who is this, what do they have access to. It's never using an actual password that can be reused forever. It's using a token that's only allowed for one purpose and expires very quickly, right? So it can't last long, it's only allowed for one thing. And the identity can be applied to an actual service. So we call something a system-assigned identity. Just kind of means a service, let's say an app service, web app, or a function, or a container app. They can have a default system-assigned identity, which is just the identity of that running process in that server, and it's always the same. So that's a system-assigned managed identity. That's really good, in my opinion, for like quick. I want to turn on managed identity. dev test. You can use system assigned. You just turn it on. Really, really easy. Don't have to think about it. But it's got some downsides, and I'll talk about that too. My favorite is the user assigned identity. And that's kind of like, remember machine accounts? It's kind of like a machine account or a user identity in that you know exactly what the role of that identity is intended for. Like, hey, this is the role so that all my functions can talk to databases. That's the identity I want to have. And it's very durable. And it's very auditable, and for prod, it's actually my favorite thing to use. So it's kind of like first set of guidance, use identity. Either kind of identity is fine. User-assigned identity is better for prod. It's durable. Like imagine you go and delete a web app or you delete a function. That identity, if it's tied to the service, also gets deleted and goes away, whereas a user-assigned identity is an independent resource, and you control the life cycle of it. And it never goes away. You have complete control. So I like user-assigned. A really important thing is, and remember this when you're troubleshooting, if you're ever using the default identity in Azure or in a favorite framework like the Python SDKs or the .NET SDKs, when you use that default Azure credential, it will automatically default to system-assigned managed identity. That's just the way the frameworks work. And that's why I'm also saying for dev test, that's a really easy way to just be like, hey, I'm going to have my app do things with default identity. I'm going to have a system-assigned identity on the service. Things will just work. But if you're starting to use user-assigned managed identity, which again is kind of a best practice for prod, that's your default identity will always break. And you're going to be wondering, hey, why am I getting permission denied 403 unauthorized kind of errors? You have to go further and kind of disambiguate which credential you want to use if you want to use a user-assigned identity. And just to kind of bottom line it for you, as we can see in the JSON app settings on the right, it's that client ID. The client ID is the thing that maps to your identity, that disambiguates which identity you want to use. So just be careful about this one. If you want to use default identity, remember it's system assigned. If you want to use a particular one, always set that client ID, and it's going to kind of reconfigure what your default identity is. Third thing, once you get into the realm of using user-assigned managed identity, you always need three things. You need that client ID, you need to set the credential property, and you need to set the equivalent of the resource name or the URI to the resource. Each resource in Azure has a little bit of a different flavor. Like a storage account has an account name, or each of the URIs, like blob service, table service, queue service, they all have a URI you can set here. And that's kind of saying, hey, this is the exact vector into the service I want to use. The client ID is saying which identity are you going to use. And credential is just instructing the system, I'm going to use managed identity. So simply, just the string value managed identity is what you need. This is kind of useful because really all of Azure works entirely this way. With RBAC and IAM roles, everything follows this pattern. The Azure SDKs, all of our services, whether it's like hosting services like App Service or receiving services like Cosmos DB, they all work exactly this way. And if you remember this pattern, you'll be set. Also notice that I'm using the SDK pattern here. So if we have a connection string, instead of saying, in the past it would be like Azure Web Job Storage and you'd have a connection string with a key. Now you have this __, and that's the way in the Azure SDKs to say, hey, I'm setting a property of a connection. So it's basically just kind of saying, hey, this is a pointer in to the connection, and I'm going to override these values. Let's see, was there anything else I wanted to say? In an app service or a function or a container app, actually I should even ask you, who's using app services today? Web apps, okay, functions, okay, container apps, VMs, AKS, Kubernetes. What did I miss? It's kind of awesome, you're using everything, thanks. But this pattern will work in all the cases, and I'm going to take you through it. And then let's take things from the app service or the functions family. A couple things to know, and this boggled my mind when I first started working on this. Every service has its own state management. Like take an Azure function. The way a function kind of keeps track of cron jobs or the way that we're going to scale out multi-instances, there is a bit of state management. We know how many instances are out there. We know which instance is handling which event. It's the guts of the internal system. But that state management is usually backed by a storage account. And the runtime for a function or web app won't even start. It won't even boot if you don't have the identity set up right. And maybe you've seen this. I see a couple heads nodding. Like you'll get in this awful state where you're in a continuous crash loop because your app is trying to deal with its own internal state management and it can't reach it. It can't access it. So we have to think about that Azure Web Job Storage for web apps and functions that are stateful. And even functions, if you think they're stateless, they're still stateful. They always need it. Also web jobs, those all need it. So we're going to set that Azure Web Job Storage and we're going to follow these principles. The next vector is the deployment itself. If you're using an Azure managed service, a PaaS service like app service functions, we use zip files, like literally zip files to deploy. And our endpoints take these zip files and they slam them into your running resource. They dehydrate them by unzipping them on disk, and then they start the app for you. Well, think about when your one app starts up, or when you do a scale out, multi-instances start up. They all need to pull that zip file, unpack on the disk, provision, and run them. So that's yet another internal mechanism where your app at runtime needs pull access to that storage, and you want to use that with managed identity as well. Now that you could use your Azure Web Job Storage account, or you just might have some other deployment storage account. But you're going to follow this exact same pattern to set up and configure the identity, whether it's system assigned or user assigned, to access that. And then the third thing is if your app has outbound dependencies and all the things I mentioned, VMs, Kubernetes apps, web apps, functions, container apps, all of them, they all have this concept of a connection, an external connection. And we're going to set it up exactly the same way with the URI or account name, the client ID, or the credential. So the awesome thing is if you kind of like memorize this slide and apply it, you've got it licked. And just remember those vectors, the deployment package, the internal state management, and then all your outbound dependencies like SDKs, triggers, bindings. All right, this is another one. If you want to follow along, you have laptops, or you want to go back and try it along. This is kind of my favorite starter template, where we're just going to look at the absolute basics getting applied. All right, so we're going to pop out. I'm going to talk at you less with slides. I get bored myself. I like to use code. So we're going to go into VS Code. And this is that exact sample that I was recommending. Actually, I should start even back a little bit. So the link that I gave you, that aka.ms, secure-functions samples, it's going to take you here. This is a gallery of like curated samples that our bigger team has done. And I'm going to take you through these really basic HTTP trigger kind of samples. So this is just setting up a simple web API. And we have one in absolutely every language and for every platform. And it's kind of the hello world of Azure services. And then as you get more sophisticated, maybe you're using AI, cognitive services, Cosmos DB, LangChain, whatever. We're going to follow these secure practices on every sample on the site, which is kind of cool. So we're getting secure by design. If you use any of these, you're starting off with a good reference. All right. And we provide bicep and infrastructure as code, which I'm going to walk you through. So let's come back here. And here's my actual code. My actual code's like incredibly simple. It's an HTTP handler. So I have one function. Let's go into Zen mode. You guys know Zen mode? This is my favorite. Control-Shift-P, Zen mode. Ooh, built into VS Code. Now it's just my code. So like I said, this is a ridiculously simple function. It's going to sit on the HTTP GET route. And it's going to take input from the user. And it's going to return, a happy 200 HTTP result or an unhappy if you had an exception. That's all this thing does. But the amazing thing is, so this was I don't know, let's look at, how many lines of code was this? This was 28 lines of code, but really it's probably 10 of actually real lines of code. But there's a whole bunch of infrastructure to secure Hello World. But we wrote that for you. So we have the bicep that comes with this. Let's go back into Zen mode. And bicep, I don't know if you're familiar with it. This is our domain language to basically have infrastructure as code. This is kind of our native language to create resources and configure them. Also, if you use Terraform, Terraform's perfectly good. But we're doing infrastructure as code, which is kind of like immutable, and it goes in source code control, and I really love it. So I recommend this. And as you can see, we take some input from the user. We're going to create a resource group. We're going to create the user-assigned managed identity, which is my favorite. We can create the app service, which works for web apps or for functions. This is an API, so I'm going to create an actual function that goes in the plan. And we have a storage account. Like I said, everything needs some internal state management. And now is when it kind of gets interesting. So we're going to set up managed identity, and we're going to apply RBAC roles so that the function app has access to the storage account. And the critical access to have read-write, in this case to a storage account, is storage blob data owner. Storage is the Uber service, blob is the specific service, and then this is a tip and trick for you. All of these RBAC roles, if you want to get to it through the data plane, or you want to like have your client app reach the data, it's going to have data in the name usually. So if I have owner, owner's not good enough. All owner means is I'm an admin of that resource and I can change properties, like kind of management properties. But if I actually want to access the data, I'm looking for a role that has a data access role. So this one gives me data owner, meaning I'm data read-write. And I do need read-write because I'm reading and writing the state of the function over and over again rapidly, and I need that read-write capability. And then we're going to set up a VNet. I promised you I'll dig into that later, so we won't worry about that right now. Oops. Oh, I switched. Somehow I alt-tabbed. There we go. All right, VNet, VNet private endpoint, we'll talk about that. Here's the monitoring. Monitoring also, if you want your monitoring to work, it needs identity access. So we show you how to do that. And that's the basics. And this is kind of a simple file to set up my whole resource group. Each one of these resources has a bicep module in detail that we kind of maintain that does everything underneath. So if you look under here, identity, storage, app service, all of that has like definitions that we provide to you. And maybe you and your admins want to customize that further. That's totally good. So you've got the resource as code. And the nice thing with this sample, you can simply just do an AZD up. Has everyone seen AZD by now? Azure Developer CLI. So what we try to do is we give you the code, and then we give you the infrastructure as code. And then you can run this simple command, AZD up. It will take all the infrastructure as code. It'll provision it. It's item potent, so if it needs to reconfigure it, it will. And then it zip deploys and pushes your payload into it. Okay, so that's that. So now we've seen the source code. We've seen the infrastructure as source code. We've seen how we deployed it easily. We've got the bicep, which we can use later in our DevOps pipelines and our CI/CD rigs. Let's look at the live resource group. People in the back, can you see this okay? A little bigger? Just do this if it needs to be bigger. I'll know what you mean. Okay, so what we got here is, I mean, we thought we were building a function, but in reality, we had to build a whole bunch of stuff, even to make Hello World work. So, like I mentioned, we want to have that user-assigned managed identity. We want to have monitoring, of course, if anything goes wrong. We want that observability. We've got that storage account, which is doing the state management of our app. I picked a harder service. This one's using OpenAI, but that's not the one I want to show. I'm being like a nutty professor right now. All right, let's go to this one. Okay, so the same idea. And also, like I promised you later, we're going to go through the VNet and the private endpoints that we set up so that this thing is network perimeter by default. What I'm proud of this app is if you follow this pattern, there's absolutely no passwords. I'll make this a little smaller, just for a sec. All right. So if I go in the environment variables, a year ago, I could never do this demo. I'd be like sent away. But now I can actually show you the values of all my environment variables with confidence because there's absolutely no passwords. And that's the way we should roll, right? No passwords. The ability to even use passwords is turned off on this app. Instead, what we're seeing is this managed identity configuration, right? So to get to my storage account, I'm seeing those three properties that I went on and on about. I've got my client ID, which points to my user-assigned identity. I'm flagging that I'm using managed identity, and I'm pointing to the resource that I want to connect to. That's it. So it's kind of like we have connection strings, but the connection string is just a pointer to the service I want to use, telling it the identity to use. It doesn't actually have the key anymore. There's no connection string key or secret. And then, pay attention to this client ID, because we're going to use it in all the dependencies. So I used it for my storage account, but also if you look at App Insights, which I'm using for monitoring, it's using the same exact client ID, right? So that's identifying the user identity. It's kind of your credentials, your passport that you're showing. And then the service itself will enforce if that identity has rights to come in or not. And let's take a look at the managed identity itself. So when you create the managed identity, oops, we'll go here. I was just looking for yellow. I got my function. All right. If we take this managed identity and we kind of say, hey, what's the associated resources? This is really handy. We can see that this is associated with my function. So the only resource in my resource group that holds this identity is the function app itself, and that's exactly what I want. This is a great audit tool to make sure you and your team didn't inadvertently share identities all over the place. Because remember, we want like one app talking to one dependency, and the more you share a credential, the more trouble you get into where like services can talk to other services that they shouldn't be. Another thing we can look at is the role assignments. And a role assignment is always about one resource having access to another resource and having a very particular grant or RBAC role. So in this case, I can see that this identity is allowed downstream to be a data owner of the storage account. I can also see that I'm allowed to basically write or publish metrics and logs to App Insights, right? So this is really cool. By using the user-assigned identity, I have this durable thing I can always look at, I can always audit, see what it has access to. And when it comes to troubleshooting, this thing is like super invaluable. Ask me how I know. Hours and hours and hours. So that's the identity piece. And this is like kind of the simple hello world. I want to riff off of this a little bit. And I'm going to show you all the places that we apply the same thing. So now let's go to a more sophisticated app. So this is another sample in that gallery. This one uses cognitive services and AI. All right, so in addition to the function and the identity, we're also seeing that it's using Azure OpenAI cognitive services. And in here, I have a GPT 4.0 model, which I'm going to use for embeddings. I'm going to use for chat. Basically, this is a chatbot app, and I'll actually kind of show you how it works in a second. Let's look at how we configured the function. So the function has an identity. I really wish the portal didn't make the left side disappear. Come on. So here we go. So if I scan down, the function has this identity. I've turned off system assigned, because again, I like that for dev tests, but I don't like it for more serious stuff. I have a user-assigned identity. So this app is going to be able to run as this identity. And then if I look at the environment variables, let's look at them in JSON view. Same thing as we saw before. App Insights has an identity-based connection string. I'm seeing a couple new things. So globally, I can set the client ID for everything in the entire Azure host app. And this is kind of saying, override whatever you think the default Azure credential is, override it to use this identity. This can be a good thing, but it can be a bad thing. It's kind of like pinning a version, right? Like you have to make sure that you understand you've pinned this identity to the whole app. And if this config lives anywhere and you're trying to use a different identity, this will be the reason why your app doesn't work. So just kind of keep in mind, you're pinning here to a client identity. And in limited cases, that's fine. And then, unlike the last Hello World app, here I'm using Azure OpenAI. And as I mentioned, every service has something like an endpoint or a name or a URI. And all we do is we set that endpoint or URI property in addition to the client ID. And now we're using user-assigned managed identity to call our downstream service. So like this technique, setting the client ID and setting the endpoint in config is the way across all the host types, Kubernetes, VMs, app service functions, I don't care. Excuse me, they all work this way, even on your local machine. So far, so good? Kind of making sense? Now, let's try this. Let's kind of pressure test this. Let's look at it locally. So here in VS Code, I have the same ChatGPT app. The last one was .NET. This one just happens to be Python. Doesn't really matter. But in this case, as a developer, all I thought about was, hey, I'm going to write my function code. This one's a chatbot, so I can, here, let me show you the HTTP file. So the way I'm going to use this app is I could do a simple completion. I can make a prompt, and the model will respond. Or I can do a stateful chatbot. This is pretty cool with functions. So I can start a chat session, and then I can issue basically prompts or messages to it. And I can even get the chat state and see all the history, right? So this is kind of how I'm going to use the API. So what we've got is we've got a function. The function's got some state management. The function's got a deployment concern. And then it's got a connection to Azure OpenAI. We saw how to set that up in the cloud. To set it up locally, I'm going to use an app config file, or in the functions case, a local settings.json file. If you're wondering how to do this. So if I'm running locally, this is like a little bit of a mind bender. We can connect to services using an identity-based credential, but we're not going to use managed identity. Managed identity is about services talking to other services. In this case, I'm Paul. I'm running on my local machine. So I actually want to run as my interactive login identity, which is paulyuck@microsoft.com. That's an Entra identity that's inside of Entra. So I'm using Paul's identity. I'm not using the function in the cloud's identity to talk to my downstream dependencies. So based on that, I'm going to use the same kind of approach where I take the account name or the URI and I specify just that, but no secrets. And this next part is very, very, very important. We want to use the default Azure credential. So we need to make sure we don't specify managed identity and we don't specify a client ID, right? Because remember, if you specify a client ID, no matter what, it's going to override and use that like user-assigned identity, and your app will break. And you're going to spend time debugging why it's broken. So in this case, we just want the user-assigned identity to flow through. And if you think about it, I'm in VS Code, or I'm at the command line, or I'm in Visual Studio. When you sign into those applied your user's identity to that process, and now it's going to use your interactive login identity to go through. So these are kind of the best practices. You want to use only the URI or account information, never client ID, never managed identity for local, if you want to get this to work using identity-based credentials. The second thing to pull this off is if you look back in the cloud, let's go back, let's actually go to our cognitive service. And let's go to the access control. This is where all the access and roles are set. And if we look at the role assignments, give it a second to load in. Remember, owner sort of doesn't matter. That means I'm an admin of the resources. That doesn't give me access into the data plane of my service. What I actually want to be is a cognitive services user. And I can see that both the user-assigned identity, which is held by my function, my web app, that has access to be a cognitive services user, but so does Paul Yuck at Microsoft.com. And see how this one is like, hey, that's a managed identity. This is a user identity, not to be confused with user-assigned managed identity. It's just a user identity. So the bottom line of what I'm saying here is both my user's identity as a developer needed access, and so did the app. Now, you might decide, like let's say a prod resource, I probably wouldn't add my user identity. I'd be like, nope, only my CI/CD rig has access to do this, definitely not Paul. That's fine. But for dev test, this is a pretty reasonable configuration. And if you're ever kind of like, hey, I'm locally trying to connect to an Azure resource and I'm getting access denied, just remember you might have set up a managed identity for the app, but not for you. And this supports users and groups, so you could also like let a team have access to something. And use this sparingly, right? Because this means I have data access to anything in this app, like anything interesting going on, any logs, I have access. In this case, I even have the entire model. Like I can access the entire model. Again, so far so good. So this is kind of my identity and access. Use managed identity, use user identity, definitely not service principals, definitely not passwords. I think we showed the different config tricks. Remember that, you know, kind of here, every one of these samples in the infra folder comes with the infrastructure as code. So you don't have to do click ops. You don't have to go through the portal and click and set all this stuff up. This is effectively your deterministic script that will apply the correct users and roles. And you know, if you can reuse this all over the place, and we definitely do. All right, so that's kind of my crash course in users identity, managed identity, and like remember if we kind of step back to the beginning, Midnight Blizzard, if we had done the right things with identities, a lot of that would have been curbed. Now I want to talk about another defense in-depth technique on network perimeters. And I have to talk less and do more because I'm going to run out of time. Okay, so network isolation, it's basically about restricting inbound and outbound traffic. Outbound, this was actually a surprise to me. This is something I learned the hard way. Outbound is the first place where attackers try to exploit you, because once you're on the machine, they try to get to other machines. And so you want to really think about outbound only allowing traffic to very specific places. And then it's up to the service to at least use identity to decide if that request should come in. It could also use networking to decide inbound if something can come in as well. But I would kind of say, like, best practice, if you have to do something right away, use identity, set outbound networking controls. And that will, like, eliminate the Midnight Blizzard style attack. Inbound is also interesting. It makes life more difficult. This is basically, so think about a web app or a service. If you put inbound networking restriction, that means no public traffic can get to it. Now that's an awfully good idea for your databases, your background dependencies, or even your key vaults, right? You don't want people hammer attacking your key vaults. They have no business doing that. But it's going to make your user experience very difficult and tricky, right? Because it basically means you need a VPN or some kind of private endpoint solution to even have network access to authenticate into the app. So we're still figuring out what we want to do in Microsoft. Should we make everything network restricted inbound by default or not? We haven't quite done that yet. Azure Container Apps is probably the first service that we've done that restricts inbound or ingress by default. But we might actually do that over time. So this is a good concept to get used to. All right. Now, how do we do the network isolation? Here's a little bit of a picture. Did I put labels? Shoot, I didn't put labels. Sorry about that. So I'll kind of walk you through it. On the left-hand side, we have a client. Think your browser or some other mobile app. It's coming into a function or an app, and the function needs to run its code, but the function also needs access to a back-end storage account. And storage and data is of the utmost importance to kind of protect. Like that web browser has no business getting into your internal storage whatsoever. It should never make sense ever, ever, ever. So what we're going to do first is we're going to deny outbound network access to anything from this function other than it having a pinhole access through to storage. We don't want it accessing Active Directory. We don't want it accessing my other databases. We don't want it accessing my other microservices or APIs. We want this function to be locked down. The only thing it can talk to is what I want it to talk to. That's it. And so that's all about outbound network security isolation. And then we could also think about inbound. We can IP restrict it, or we can like turn it fully off and require VPNs to come into that IP space. And that's like the most protective you could possibly be. All right, so for inbound traffic, the most secure thing we can do today is we can, if we're using Azure software and not additional like hardware in front of it, we can use a VNet. Again, if you put on a VNet, it completely will deny by default all traffic. All traffic is untrusted. And then you basically have a few things you can do. You can allow list trusted IPs, otherwise you can just, it's kind of like poking a hole in your firewall. Otherwise you could just have a VPN. And then you rely on auth methods like easy auth as being a good way to decide not only should the traffic packet come in at layer 7 or layer 3, but I also am going to make sure that that is authorized to reach my app. For outbound, you want to join the VNet, and that's less aggressive and disruptive to your user experience. It's more about protecting the rest of your fleet from that app. So you join the VNet, and then we create tiny little pokes through the firewall with things called service endpoints and private endpoints. And if you want to be, if you want to have a little bit of convenience, you can take a list of IPs that should have access, and you can do an outbound NAT, network translation, which is like a many-to-one relationship. You can have many IP addresses in a service tag list that go out through one IP, and that one IP is the single IP that has access to the outbound dependency. That's a best practice we do. Now, if it's just one service calling one dependency, you don't have to worry about it. But if you're a service as big as app service itself, we have millions of public IP addresses. So rather than having allow lists of millions of IP addresses, which doesn't really scale, we do our own mapping through a service tag with 1,000,000 to 1. So 1,000,000 things map into the one IP address, and the one IP address is the only thing that can talk to our storage. All right, and with the rest of the time I have, I want to show you a demo of this. So we're going to go back to the same hello world, the secure hello world. All right, so here we go. And let's look at some of the concepts we added. So we added a VNet, right? And this is our corporate or our private network just for our service. And rule of thumb, only associated things that should talk to each other belong in the same VNet. Everything else absolutely should be out of your VNet, no questions asked. And even once we have a VNet, there's more to think about. So in the VNet, we start getting into physical networking concepts like subnets. And the best practice here is that your app is always in one subnet, and your dependencies are always in their own subnet. So you've kind of firewalled, even within your virtual network, you're firewalling your app's IPs from your dependencies' IPs, right? And if you have multiple dependencies, like I showed you that AI case, I have the storage account, I have monitoring, and I had the AI service. 3 dependencies, 3 subnets plus the app, so that's 4. And you can kind of see, like, there's a little bit of complexity that kind of comes with this. But if you want to do the full, like, 300, 400 level security treatment, this is what we do. We define one subnet for each dependency, one for the app. And that's really the best practice. And then we have these things called private endpoints. And the private endpoint is effectively that little tiny hole through the firewall. So I have to come in, so to get to that storage account, I have to come in through a trusted IP. And this private endpoint in the private DNS zone gives me a feature where I can refer to a well-known domain here, and I can find that storage account and talk to it using the right IP to get through. So only this function can use this private endpoint, which gives me that IP, which can get to that storage account. So the combination of private endpoints, DNS zone, plus VNet, this is the story to set up the network isolation for outbound. And you end up, again, with basically one endpoint and one subnet for every single dependency that you have. And one unfortunate bit of news for you is that if you take the storage service, even though we logically think of Azure Storage as one service, it's actually four. It's the blob service, the table service, the queue service, and the file service. Each one of those, from a network standpoint, is a different service. That means an endpoint and an IP address for every one of those. So you kind of start to see a little bit of a matrix explosion with this. And by the way, I want to make, now that I've felt the pain, we're going to make this easier and easier so you can, in a more automated way, get like, hey, we've identified you have these 4 dependencies. Should we give you a secure network perimeter to just have private endpoints to all these? We're working on that productivity. Unfortunately, that's not there right now. So I think the best I could do for you is like the bicep and the guidance on here's how you do it. The very last piece, was there anything else I wanted to say about that? I think that's the key. Remember, we have the bicep for all of this also. So remember, in here, in the main bicep, we had a module. Sorry for the scrolling. As I mentioned, there's a matrix explosion. Here it is, virtual network. So it looks really simple, like, hey, just drop a virtual network in here. So this is backed by the vnet.bicep file. And I'd recommend studying this a little bit, because this really, to me, kind of makes the concepts clear. So here, we're going to define the virtual network, and we're going to define each of the subnets. And as I mentioned, it's critical. The app has its own subnet. Each dependency has its own subnet. So you can see we walk through and we kind of say, OK, the app, here's its subnet. It's on the 2 dot subnet. And by the way, every function, we've done the math to make sure you have enough IPs per subnet and you don't run out. We used to hit some limits, but we've done some work to make sure you won't run out. And then each of the dependencies, like whether it's storage or whether it's AI, we give it a new subnet. And then there's more things we have to do. We have to enable the private endpoints so that you can call that DNS name. It will reverse proxy you into that endpoint. A little bit of heavy lifting, but again, I think with this template, this is what you want to do, and it's repeatable literally for every host service, every dependency that you have. And more that secure sample gallery I pointed you to, there's more like common apps that we're showing on there, or think of them as solutions. Hey, if I have an AI app, this is what my network looks like. If I have a function, if I have a container app, this is what it looks like. So you can get a feel for that and just reuse the pieces of that code. Very last thing, if you want to do that inbound networking, right, you're getting into the world of VPNs. How many of you require VPNs for your apps today? Just kind of curious. This number of hands goes up every year. It's becoming more and more. At Microsoft, we actually don't a lot of the times, but that's changing. Again, I see it more and more. The other thing, even if you don't secure the network perimeter inbound, I highly recommend at least turning on off. Require every inbound connection to your app uses auth of some form. And in our platform, the easiest thing to use is called Easy Auth. I think that's beyond what I have time to talk about in an hour. But I'll leave you the reference for that. You turn on Easy Auth, and Easy Auth accepts Entra. It accepts a lot of the social IDs, like Google's identity, Facebook, many of them. And it also supports something called OIDC, or OpenID Connect. So if you've ever thought about like how does Google, which technically is its own company and its own identity, talk to Azure, it does it through OIDC Connect, which is an OpenID protocol. And that OpenID protocol understands managed identity and Entra identity, so it can kind of broker that back and forth relationship. So EasyAuth makes it easy to kind of bring your own auth tech and put that as the auth front door in front of your APIs, in front of your apps. EasyAuth is easy on the service. To be honest, a limitation is EasyAuth is not easy yet on the client, but we have docs for it. But I promised I'd talk about limitations, and that's one of them. So I think that's it. We're going to run out of time, so I'm going to leave you with some resources. I'll send out the slide deck afterwards, but we have decks, we have docs, rather, for app service, Azure Functions. I'll add one for AKS and VMs, since you raised your hands, and container apps. We've got these quick starts, which show you all the solutions. I'd highly recommend starting there. When all else fails, you can X or tweet me or whatever you say nowadays. I'd love to talk to you and kind of help point you in the right direction. Also, we've kind of trained search engines and even like ChatGPT. So if you just say, write a secure Azure web app or write a secure function, this guidance and these samples will come right up. So yes, that's pretty cool. So hopefully everyone learned something, that you got something out of this. Please give me some feedback afterwards. I'd love that. And hopefully we're in it together to lock this stuff down and get a few steps ahead of the attackers. Thank you very much.